All right, guys, we're going to talk about the substitution method for solving systems of equations. Again, I mentioned this last week in the Desmos activity, or if we did it in class together, great. I'm just going to walk through a few problems. There's a couple of little things we want to look at, a couple exceptions to rules. But if you know what you're doing here, you can skip this or skip forward, okay? So one of the types of systems we look at is these two things that are in our slope-intercept form. But again, the numbers are so big here, I don't really want to graph these. So what we said last week was if two things are equal to the same thing, they're really equal to each other. So I can set these two expressions, 16x plus 164 equal to 5x plus 76. And our goal, again, is to go from having two equations with two variables down to one equation that only has one variable. Because if I only have one variable, I know what to do. We've been doing this all year long. So we use this expression a lot. From two equations and two unknowns down to one equation with one unknown. One unknown, one variable, we can solve all day long. And then we're just going to work through our algebra. Practicing this algebra is never a bad thing to do. And that gives me 11x equals negative 88. Nicely, x will equal negative 8. So a nice neat number there for us. We also, remember, need to find the y, and to do that I'm going to substitute the value of that x back into either one of these equations where the x is, whichever one looks easier, and at the moment I'm going to choose that second equation. So I'll do our value of y will equal 5 times that negative 8, so negative 40 plus 76 gives me the y equal to 36. And again, we could write that as an ordered pair. X comes first, y comes second. Okay, so we looked at some of those last week. Here's another example of that same idea. Two things, or no, this one's a little bit different, sorry. So we've, in this case, y equals 13. If we were graphing that, remember, that would be that horizontal line, y equals 13. And we would look for where it intersects with this equation. It will be something, comma 13. So in an equation like this, or a system like this, it looks a little weird because one of them doesn't have any x's in it, but that's okay. That means we're already halfway done before we even start the problem. So we would have negative 8x plus 14 times 13 equals 22. And you guys can solve that one from there. So again, sometimes they look a little strange with one of the variables missing. That's okay. It means we're already halfway to the end of the problem. Just substitute it into that value in the other equation, and you're good. All right, then we looked at, in this case, our equation's not equal to just a number. It's equal to an expression, that y is equal to 6x minus 16. And the other equation is in standard form. We could put the other equation into slope-intercept form and graph it. But what we want to practice on, some of the equations on your worksheet and the equations we'll look at going forward, is using that substitution method in a problem like this. So what we said is we're going to take the thing that y is equal to in that equation where y is already isolated, and we're going to put it in instead of that y in the other equation. So I'm going to rewrite that first equation exactly as is, minus 8x minus 6. But instead of y, I'm going to write what y is equal to. Y is equal to 6x minus 16. And then I'll finish the equation off, writing the end of that equation that equals the equals 8. Now I just solve. I'm going to distribute minus 8x minus 36x plus, I believe that's 96, equals 8. That's minus 44x equals minus 88. A lot of 88s today. Divide by that minus 44. And I get a nice easy answer of x equals 2. And again, now I need to solve for y. I go back and substitute it into whichever y looks easier, whichever equation looks easier. To me, that's this one. So that's 6 times 2 is 12 minus 16, so y would be minus 4. Okay, so it's substituting an expression into the other equation. Make sure you don't substitute it into itself. I've done that before. I remember doing that in high school. Something weird happened. All right, here's another example. So we're going to take the value of the y, value that y is 2x minus 1, and we're going to substitute it into the other equation instead of y. So I have minus 4x plus 2 times 2x minus 1 equals minus 3. So I've written that entire equation. The only thing I changed about it is I replaced the y. Minus 4x. Now when I distribute, oh, this one's a plus 4x. So this is one of those exceptions to the rules that I mentioned at the beginning of the video. What happens here? Well, let's say I have minus 4x plus 4x. They cross out. And then I'm left with minus 2 equals minus 3. So this brings us back to the fall when we talked about those equations that have no solutions or all real numbers as a solution. This statement, we've done our math right. This statement gives us negative 2 equals negative 3. That's not true. This is another one of those false statements. This is an equation that has no solution. What would that mean if we graphed them? Well, we know what that second one looks like. If I put this first equation into slope-intercept form, by adding the 4x and dividing by 2y, I would get y equals 2x minus 3 over 2. And we notice these two equations happen to be parallel. They have the same slope, so they'd never intersect. So there's no solution here. That happens sometimes. No big deal. Just watch that when you get one of these false statements, you write no solution. And of course, because we saw no solution, we want to look and see if there's any other kind of information here too, any of these other exceptions. Same idea here, I have a y equals. I'm going to substitute that into the other equation, so 24x plus 3 times that y value. The y is negative 8x plus 15. And again, remember, don't stop there. You want to keep going, finish the equation off, write the rest of it, equals 15. And when I distribute here, sorry, that wasn't 15 in the middle, that was a 5. When I distribute here, I get 24x minus 24x, so another one of these weird things is happening. Plus 15 equals 15. And again, we have those additive inverses of each other. That's a zero pair. And I end up with 15 equals 15 here, which is a true statement. Now in the fall, when we talked about these, we would write all real numbers. It's a slightly different ending in this case. Instead of all real numbers, because with our systems, the answer is an ordered pair. It's not a real number. They're not quite the same thing. There's two real numbers included in that ordered pair. So we don't say all real numbers. Instead, we say there are infinitely many solutions, or infinite solutions, something like that. Because we've known each other so long now, I will let you write inf-sol. All right, and that's it. So we're just going to practice these today. If you're at home, you're going to work on the worksheet I gave you the other day. If you're fully remote, I'll post the PDF with the same thing. I will post the answers on Tuesday. So that's your Monday, Tuesday assignment, is just work on practicing these things. And look for, especially on the back page or the second page of the PDF, there are going to be some of these no solutions and some of these infinite solutions. Okay, so it's not a fluke. It's not that you're getting them wrong. There are some weird things that can go on here. All right, no big deal though. We got this. And I will talk to you later. Bye-bye.